Okay, so let's look at another example. Suppose that we want to choose 5 cards from a standard 52 card deck. So part A, in how many ways can we do so? Part B, in how many ways can we do so? Assuming that we want exactly 2 of those 5 cards to be kings. And part C, in how many ways can we do so, assuming that we want at least 2 of those 5 cards to be kings. Okay. So let's see how we can do this. So part A, in how many ways can we choose 5 cards out of 52 cards? So we know that if you want to choose R objects out of N objects, then the total number of ways is C and R, or combinations. And of course, the order is not relevant here. How do we know? But because it doesn't matter which card is chosen as the first card, which one as the second card, which one as the third card. So it doesn't matter, right? So it just says 5 cards out of 52 cards. So it doesn't matter which one is the first one, which one is the second one, right? So we just want to know which 5 cards we choose. Once I know which 5 cards I choose, well, then I know my choice. So for part A, number of ways. Number of ways to choose 5 cards out of 52 cards is given by 52 choose 5, or C 52 and 5, which can also be written as 52 factorial divided by 5 factorial, 47 factorial. And this is 48 times 49 times 50 times 51 times 52 divided by 2 times 3 times 4 times 5, right? 52 factorial over 47 factorial is 52 times 51 times 50 times 49 times 48. And there is also a factor of 5 factorial in the denominator, which I also included that. So you can leave your answer like this in the exam, that's okay. Now part B, we want exactly 2 of those 5 cards to be kings. So what does that mean? That means 2, I'm going to choose 5 cards, right? So 2 of them must be kings and 3 of them must be non-kings, anything but kings. So see, I have 5 options, 5 cards to choose, right? So we need 2 kings, 3 non-kings, 3 non-kings. For 2 kings, how many options do we have? So 2 kings out of, first we have to know what are the total number of options. 2 kings out of, well, we have 4 kings in total, right? In the standard 52 card deck, we have 4 kings in total. So 2 kings out of 4 kings. And 3 non-kings out of how many non-kings do we have? We have 52 cards in total. 4 of them are kings. How many of them are non-kings? The remaining, which means 48. So 3 non-kings out of 48 non-kings. So let me call them task 1 and task 2. For task 1, we have how many options, how many ways to do that? 4, choose 2 options. For task 2, we have 48, choose 3 options. Choosing 2 cards out of 2 objects out of 4 objects. 4, choose 2, choosing 3 objects out of 48 objects. 48, choose 3. So by product rule, in total, we have 4, choose 2 times 48, choose 3 options to choose 5 cards as described. Okay, now part C. In part C, we want at least 2 of these 5 cards to be kings. So at least means either 2 of them must be kings, or 3 of them must be kings, or 4 of them must be kings, right? Because it's not possible that all 5 of them are kings, because in total I have only 4 kings, right? So that's not possible, but 2 of them could be kings, 3 of them could be kings, or 4 of them could be kings. So we want either 2 kings and 3 non-kings, or 3 kings and 2 non-kings, or 4 kings and 1 non-king, okay? So in total, we say by principle of inclusion exclusion, we have to add so let me call this one 1 and this one 2, this one 3. We have to add number of ways given by 1, 2, and 3. Please remember that the number of elements in A1 union A2 union A3 is number of elements in A1 plus number of elements in A2 plus number of elements in A3 if A1, A2, A3 are pairwise disjoint. See, remember always in mathematics, OR means union. So I have 3 sets. First one you can denote with 2 kings, 3 non-kings, then 3 kings, 2 non-kings, and 4 kings, 1 non-king. So there's OR between them, which means there's a union. So I want to count number of elements in this set, union this set, union this set. So as long as these 3 sets are pairwise disjoint, meaning that between any 2 of them, there is no intersection, then I can say that the number of elements in the union is simply the addition of number of elements in each set. So here, these sets are pairwise disjoint because if you have 2 kings and 3 non-kings, then you cannot have 3 kings and 2 non-kings at the same time, right? So there is no common element between it. The elements of this set and elements of this set, or elements of this set and elements of this set, right? Pairwise disjoint means what? Means 1 intersection with 2 is empty, 1 intersection with 3 is empty, right? And 2 intersection with 3 is also non-empty. 2 intersection with 3 is also empty. So intersection of any 2 of them is empty. 1 with 2 or 1 with 3 and 2 with 3. So if this is the case, if intersection of any 2 of them is empty, means they are pairwise disjoint. And in that case, the number of elements in the union 1, 2, and 3 is the addition of number of elements in 1 and 2 and 3. Okay, now number of elements in 1. How many elements do we have in the first set? 2 kings and 3 non-kings. Well, we just calculated in part B. So we can say number of elements in 1 is, we saw that is 4 choose 2 times 48 choose 3. Computed in part B. Similarly, number of elements in 2. In 2, we want 3 kings and 2 non-kings. So 3 kings must be chosen from 4 kings in total. 2 non-kings must be chosen from 48 non-kings. And similarly, number of elements in 3. 4 kings out of 4 kings. And from the remaining 48 cards, 1 of them must be still chosen, right? 4 kings and 1 non-king. So in total, we have, so 4 choose 2 times 48 choose 3 plus, right? We said we have to add here. Here we said we have to add because they're pairwise disjoint. Plus 4 choose 3 times 48 choose 2 plus 4 choose 4 times 48 choose 1. Ways to choose our 5 cards as described above. Okay. All right, now let's look at another application of, another important application of combinations is basically a binomial coefficients. So binomial coefficients means, if you consider the binomial identity, so consider the binomial identity let's say a plus b, the whole to power n. What are the coefficients of this identity if we expand it? So the coefficients of, so this is called the identity for a plus b to power n is called binomial identity, and the coefficients when you expand are called binomial coefficients. So consider the binomial, let me say, because I haven't derived the identity yet, so let me call binomial expression. Binomial expression, a plus b to power n. Now, what do you think the coefficients would be, which we are going to call it binomial coefficients? So a plus b to power n means what? So see, a plus b to power n means a plus b times a plus b times dot 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 times a plus b. Now, when we expand this, we have an a to power n term, right? What would be the coefficient of a to power n? So for a to power n term, if you want to get a to power n, what should we do? So the only way to get a to power n is that from each bracket, I have to choose a. See, I want to multiply these n brackets together, right? And from each bracket, I have two options. I can either choose a or b. So even if from one bracket I choose b, then the power of a will be at most n minus 1, even if I choose a's from all remaining brackets. And it will not be a to power n. If I want to get a to power n, I have to choose a from every single bracket. So I have to choose a from the first bracket, I have to choose a from the second bracket, and so on. And I have to choose a from the last bracket. So must choose a from all brackets. And then we get a to power n. It seems the screen is freezed again. Stop share. So there are how many ways to do that? And there is so how many ways do I have? See, I have n brackets, and I want to choose n of these brackets so that I choose a from them. So there is n, so c, n, and n ways to do so. The first number, I think this is could be a little bit confusing. See, why do I say c, n, and n? See, look at here, there are two numbers here that I will write for each a to power k term. So the first n is coming from the fact that I have n brackets in total. The second number is the number of brackets that I need, that I'm going to choose a from them. So how many brackets am I going to choose a from them? I'm going to choose a from n brackets if I want to get a to power n. Well, in this case, because I want a to power n, both these parameters are n. But for the remaining powers of a, you will see that these two numbers will not be the same necessarily, right? So the two parameters, one is the total number of brackets, the second number is the number of brackets that I want to choose a from those brackets. If I want to have a to power n, I have to choose a from n brackets so that I get a to power n term. So we must choose a from all n brackets. Okay. For a to power n minus 1 term, so again, let's look at the expression a plus b times a plus b times a plus b. How many terms, how many brackets do I need to choose to choose a from them? I have to choose a from n minus 1 brackets this time. See, I have still have n brackets in total, right? But this time I have to choose a from n minus 1 brackets. Because if I choose a from all n brackets, then I get a to power n term, not a to power n minus 1 term. But if I want to have a to power n minus 1 term, I have to choose a from n minus 1 brackets. So which n minus 1 brackets? Then I have different options, right? So one option is that I can choose brackets, for example, 1, 2, all the way to n minus 1. Or I can choose, for example, a from bracket 2, 3, all the way to n. Different choices I have, right? So to get a to power n minus 1 term, we need to choose a from n minus 1 brackets out of n brackets in total. We need to choose a from n minus 1 brackets out of n brackets in total. And the remaining and b will be chosen from the remaining 1 bracket. So number of ways to do so is Cn and n minus 1. I want to choose n minus 1 brackets out of n brackets so that I choose a from those n minus 1 brackets. Okay. And the number of ways to choose n minus 1 objects out of n objects, in this case, n minus 1 brackets out of n brackets, is Cn and n minus 1. So continuing, so this means, before saying continue, so this means coefficient of a to power n minus 1 is Cn n minus 1, which is same as another notation for this is n choose n minus 1. So continuing this process, continuing this process, we can observe that the coefficient of a to power k, with k between 1 to n, with k between 0 to n, is n choose k. Because again, for a to power k, we have to choose k brackets out of n brackets. And the number of ways that we can do so is n choose k. So a plus b to power n. So what will be the identity for a plus b to power n? A plus b to power n will be n choose n times a to power n plus n choose n minus 1 time. Okay, so the coefficient of here, I should have said coefficient of a to power n minus 1 times b. Right, because this way we had n minus 1 a's to get a to power n minus 1, but there's also 1 b, right? Because there must be n brackets in total that you are going to multiply them. The screen again is freezed. In total, there are n brackets that you have to multiply them. For n minus 1 of them, we choose a, but there is also one bracket. There will be one bracket left. For that one bracket, we have to choose b. Because if in the remain for the last bracket, we also choose a, then get a to power n term, which we already did it before. But in this case, you want to choose n minus 1 brackets to choose a from them, and one bracket to choose b. And in all such cases, we get a to power n minus 1 times b term. How many ways do we can we do so? A number of ways to choose n minus 1 brackets out of n brackets. Because once you choose, because some people here ask, say, okay, what about the remaining one bracket? Do we not have an option or choice for that? No, we don't have any choice for that anymore. Once you choose your n minus 1 brackets, so that you choose a from them, the remaining one bracket will be automatically b, right? So there will be no choice for you anymore. So there you will be left with only one bracket, and that one bracket you have to choose b from it. So there will be no choice anymore. So the number of choices is n choose n minus 1. For the b term, you will have no choice. You have to choose b from the remaining one bracket automatically, right? So in this case, this is a coefficient. You get coefficient of a to power n minus 1. Power of a will be a to power n minus 1, and the remaining one bracket will be b. So the term will be a to power n minus 1 times b. And this is the coefficient because this is the number of ways to get this term when you expand a plus b times a plus b times a plus b n times. Similarly, for a to power k term, we have to choose k brackets out of n brackets to choose a from them. And the remaining brackets, how many brackets will be remaining if I choose k of them, and there are n in total? So n minus k brackets will be left. And those remaining brackets, we have to choose b from them. So the power of b here would be b to power n minus k. Power of a would be k, power of b would be n minus k. Okay. Again, you will not have a choice over the brackets that you choose b from them anymore. Once you decide which k brackets you want to choose, so that a will be chosen from them, the remaining n minus k brackets will be automatically corresponding to b terms. You will not have a choice anymore. So the number of ways to choose k brackets so that we choose a from them, and the remaining will be automatically b. The number of ways is the number of ways that you can choose k brackets out of n brackets, and that's n choose k. So a plus b to power n will be n choose n times a to power n plus n choose n minus 1 times a to power n minus 1 times b, n choose n minus 2 a to power n minus 2 times b squared plus dot 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 plus n choose k a to power k b to power n minus k, and the last term will be n choose 0 a to power 0, which is 1. So a to power 0 is 1, and so n choose 0 times b to power n. So for the last term, what do we mean by n choose 0? We mean we are choosing 0 brackets out of n brackets. So basically we are choosing no bracket out of n brackets so that a will be chosen from them, which means that there will be no a, because if you choose 0 brackets so that a will be chosen from them, that means there will be no a term, and the remaining, which means in this case all the brackets, will correspond to b terms. So this means that in this case, for the last term, all the brackets, you will choose b from all the brackets, and there will be no a. And in that case, you'll get b to power n term, and the coefficient will be n choose 0. Well, that's it. So this is called a binomial identity. So let's look at an example. Let's say find an expression for a plus b to power 3. A plus b to power 3, according to what we said, is 3 choose 3, a to power 3, 3 choose 2, a to power 2 times b, 3 choose 1, a times b squared, and 3 choose 0, b to power 3, right? See, 3 choose 3, a to power 3, 3 choose 2, a to power 2b, and so on. Now I can calculate these numbers. 3 choose 3, we'll see it's 1. 3 choose 3 equals 3 choose 0. We can check that these numbers are 1. 3 choose 3 and 3 choose 0 are 1. And 3 choose 1 and 3 choose 2, you can check that these are 3. So then this will be a to power 3, 3a squared b, 3ab squared, and b cubed. Which is the identity you knew from high school. But let me also explain one more time for example, a plus b to power 3, which means a plus b times a plus b times a plus b. Let me explain one more time the idea that we did for deriving binomial identity for this simple case, because always when you want to understand the concept, if you think about the simple cases, it could really help you to understand it better, and then you can try to generalize it for the general case. So see, when you want to multiply a plus b times a plus b times a plus b, what was the idea that we said? We said, okay, first of all, you have some a to power n term, in this case, a to power 3 term. How do you get a to power 3 term? I have to choose a from the first bracket. I have to choose a from the first bracket, I have to choose a from the second bracket, and I have to choose a from the third bracket. There's only one way to do that. So that's, and then I get a to power 3. And then I have some a squared b term. To get a squared b term, that I have different ways to get a squared b. So one way is that I can choose a from the first and second bracket and b from the last bracket. Then I get a squared b. So then I will have one a squared b that way. Another way is that I can choose brackets, let's say 2 and 3, to choose a from them, and I choose b from the first bracket. That's another a squared b term. And another a squared b term is if I have a from the first and third bracket, and I choose b from the second bracket. Then again, I get a squared b term. So in total, I will have 3a squared b term. So the thing that we said was that, okay, in order to count how many a squared b terms we have, we can look which brackets I'm going to choose. I have 3 brackets in total. Which of these 3 brackets I'm going to choose so that I choose a from them? Well, we can choose a from brackets 1 and 2, or we can choose a from brackets 2 and 3, or we can choose a from brackets 1 and 3. So when I say 1 and 2, I mean first and second bracket. I'm going to choose a from them, and the remaining bracket will be automatically b. When I say 2 and 3 means second and third bracket, I'm going to choose a from them. Remaining bracket will be automatically b. 1 and 3 means first and third bracket will be a, and the remaining bracket will be automatically b. So how many ways do I have in order to get a squared b term? So that's going to be number of ways. So see, remember, I have 3 brackets in total, 1, 2, 3. So number of ways that I can choose 2 elements out of these 3 elements is going to be the coefficient of a squared b. How many ways do I have to choose 2 elements out of these 3 elements? When one way is to choose 1 and 2, one way is to choose 2 and 3, one way is to choose 1 and 3. The 3 ways to choose 2 elements out of these 3 elements. Either 1 and 2, or 2 and 3, or 1 and 3. Or in other words, 3 choose 2. 3 choose 2 means number of ways to choose 2 elements out of 3 elements. So that's why we said the coefficient of a squared b is 3 choose 2. Similarly, we can see that coefficient of ab squared is 3 choose 1, and coefficient of b cubed is 3 choose 0. And we apply the same idea for power n rather than power 3. Okay, so I explained the idea for n equals 3. One more time, just to make sure you understand what's happening here and why the binomial coefficients are same as combinations, combination C and K. All right, now let's look at some properties of combinations C and K, or n choose K. So first property is that n choose 0 equals n choose n equals 1. It's a very simple property. N choose 0 always is 1, same as n choose n. It's very easy to prove. N choose 0 means n factorial over 0 factorial times n minus 0 factorial. That's n factorial over 0 factorial times n factorial. And 0 factorial is 1 by definition. So you may be surprised a little why 0 factorial is defined as 1. But we know that n factorial means 1 times 2 times all the way to n. Well, 0 factorial, you may say, okay, why, how can we get 1? This is just a definition. This is just a convention. Okay, so for 0 factorial, we do not say 1 times all the way to 0. Instead, we just make a convention that we say, okay, 0 factorial, we are defining it to be 1. Why? Because if we define it to be 1, then our formulas would work nicely, right? For example, here, the coefficient, we need the first coefficient to be 1, right? Or last coefficient to be 1. So if we define 0 factorial to be 1, then this number will be n factorial over n factorial, which is 1, right? So everything would work out nicely, you know, if we define 0 factorial to be 1. So just accept that 0 factorial is defined as 1. But for all other factorials, for example, 1 factorial is just 1 times 1, which is 1. 2 factorial is 1 times 2, which is 2, and so on. So the formula that we said is 1 times 2 times all the way to n is for if n is bigger than or equal to 1. For 0 factorial, just accept it to be 1 so that the formulas would work nicely. Similarly, check that n choose n is 1. Second property, n choose 1 equals n choose n minus 1 equals n. Again, this one is very easy to prove. Let me leave exercise. It's very easy. Just use the formula. Third property, n choose k is equal to n choose n minus k. N choose k is always same as n choose n minus k. For example, n choose 1 is same as n choose n minus 1. Or n choose 2 is same as n choose n minus 2, and so on. So for example, in the second property, we already saw that n choose 1 is same as n choose n minus 1. But for any k, we can always say that n choose k is same as n choose n minus k. How can we prove this? Proof. N choose k is what? Is n factorial over k factorial times n minus k factorial. So this is my left-hand side, right? And what about the right-hand side? Right-hand side is n choose n minus k, which is what? Which is n factorial over n minus k factorial times n minus k factorial, right? So if you have n choose r here, let's say if you have n choose r, then it's n factorial over r factorial times n minus r factorial. Now my r is n minus k, so n factorial over n minus k factorial times n minus k factorial. And that's going to be n factorial over n minus k factorial times n minus this guy is k, so k factorial. Okay, but this turns out to be same as the expression for left-hand side, which is n choose k. So by comparing, we conclude that n choose k equals n choose n minus k, which is my left-hand side, and this is my right-hand side. Okay, so this is one proof. It's called algebraic proof. Algebraic proof for this formula. We have another type of proof, which is called combinatorial proof, for proving identities and formulas. That's a little bit more tricky, more conceptual, and we'll do it next time. So remark proof above is called an algebraic proof. Next time, we'll see another type of proof for this identity and similar ones, which is going to be called combinatorial proof. Okay, guys, so I'll explain about this type of proof next time. But next time we have exam on Thursday. We have exam 8:30 to 10:30 p.m. But next week I will explain about this type of proof. Okay, so thank you and see you soon.